Hello everyone, in this video I wanted to show you some performance baseline for this setup and try to undervolt and show that something is wrong with the latest MSI BIOSes, or I guess with the combination of 12700K F and MSI B760M Mortar Wi-Fi, which is a upper mid-range motherboard and unlocked CPU. So the baseline performance and power figures here you have. We're pulling 210 watts on the CPU, 83 degrees as a maximum temperature, 27 nanoseconds for YCruncher time. So we have the E-cores off and everything is like, we just loaded setup defaults. So we'll now go and try to enable XMP first and see what happens. So there's a 64 gigs of 6400 CL32 RAM, and for some reason that doesn't want to work at over 6000. So 6000 is the only frequency I was able to get working. So let's say profile 1, save and exit, and let's run YCruncher again. System takes a while to load, and sometimes it would even crash while loading Windows. I'm waiting for it to get unstuck from the DRAM LED. Here we are, RAM profile is loaded. We can see 3200 megahertz, which translates in 6400 mega transfers. The VDDQ is 135, and the system agent is insanely high at 1.3 volts almost. VRAM voltage is, RAM voltage is 1.41. And if I run YCruncher, if I try to run YCruncher, sometimes, it just crashes. So this is not working, not stable. I was able to get it run at 6000. So I will load the profile now. The CPU doesn't need 1.3 volt as system agent. It's absolutely not necessary. Most Alder Lake systems that I was able to tune were working with 6400 at just like 1 volt. So profile 2 is 6200, doesn't work. This profile 3 should work. I will not touch the system agent at the moment just to see what happens. In my testing previously, I was running that at 1 volt and was working perfectly fine, and the RAM was at 1.3 volt. But we'll just see what the XMP does. This is just weird because this motherboard has 6400 as the guaranteed speed for dual rank single DIMM per channel. So this should definitely work with this board. 6400 shouldn't have any problem working, but I tried everything, lowering and even rising the voltages, and it wouldn't post. I mean, no, sorry, would post, but would crash immediately with YCruncher. Doesn't basically work. Let's see what happens. Let's run with 6000. Here we are, CL30. Let's see if it actually completed the task. It seems likely because it went past the first part. CPU temperature is 80 degrees. I have a Noctua cooler on that. Single tower, but still works fine. 26 seconds. So this works. Let's now try undervolting. I already tried to offset undervolt, and the offset by CPU doesn't work, and the offset by PWM doesn't work in a way that it reduces performance, like it triggers clock stretching. And let's see if that works with light load. Spoiler, it doesn't. It's still enabled for some reason clock stretching, which is the first time I see this for light load. And I don't know how MSI went backward and actually broke things that were working before. I was stupid enough to update the BIOS when I set this build. The machine came with the motherboard came with the, I think, version 3 BIOS. I updated to version 5 because I thought that was like a middle ground, and it was just, I don't like to use the latest, but I did it, and that was stupid on my part. So let's run the test and see what happens with light load set to, I don't remember even what I set before. If I set it to 1, the system crashes. If I set it to 4, the system works, but it's terribly slow. So let's see what happens now. We peaked at 150. Oh, okay, so it just crashed. So let's get it back to the BIOS. So here we are. Mode 4 should work in a way that the system boots and is able to complete the task, but it will take forever for it to complete. Here we go. Package power is 100 watts, which is less than half what it used to be before. And let's see if I can see effective clocks. Is there anything like that? Weird enough, like the effective clock seems to be matching the supposed clocks, but in the end what is happening is that it's taking forever to complete the YCruncher load. So it used to be 26 seconds and it's now going to be ages. Let's see, it's gonna be taking like maybe 80 seconds if I remember correctly. As you can see, the temperatures are super low, 43 degrees. Yeah, so that is current excursion protection, I think it's called, and it is not possible to disable it with the KF CPU, so unlocked CPU. MSI used to allow light load to work even on unlocked CPU, but now it doesn't, and I'm terribly frustrated by this. So 75, but yeah, you can see the point. So that is really awful from MSI. I'm very, very depressed about that. Okay, took the Viper kit out, put some 32 gigs of extra memory, Hynix for sure because it's CL32 I think, and I set it to 64 and it worked straight away. I mean, not really, I had to put those timings in, but other than that, worked fine. So some issues with this kit, or might be the motherboard, don't know really, but at least 6400 is doable. I might even try to get higher speeds. Let's see. Okay, 6800 wouldn't work, so I'm trying 6600. Seems to be fine now. No, actually crashed again. So yeah, 64 is the sweet spot for this kit. With some work, I think I might be able to get this working, but I will need maybe too much voltage. We're currently at 137 VDDQ and RAM, and 1.15 for the system agent. So by here, system agent 1.13, 1.14, and RAM is always 10 millivolts more than what I input. But yeah, not great, but works. Still, it should do. On the website, they say one channel dual rank should do 66. So yeah, actually I should do 66 for the 64 gig stick and 7200 for the 32 gigabyte stick. Another kit, 96 gigabyte now, XMP enabled. Let's see, everything is back to auto, so I can run this. In my experience, 96 gigabyte kits never work at the default stock XMP. I tried, I think, 4 of them so far, and they don't work, never. What happens is usually, of course, you will need to underclock them to 6200 or even 6000. I had a kit that needed 6000 to work actually, and the only one that I got to 64 was only doing that at 1.33 volts. Anything lower, anything higher would crash at some point. I mean, throw up errors. So if I get too high voltage, long test would crash. In the long term, I would get a crash with the fan on the RAM, nevertheless. And if I put the voltage too low, I could run maybe TN5 for 6 hours, but I could not run YCruncher because probably the stress on the memory sticks is too high. with oh sorry, or maybe it was limp pack, but whatever. Only a very specific sweet spot would work, and of course CL would be raised to 36, and 32 would never work. Even if those kits are rated to 32, 39, 39, they usually need 36, 40, 41 to actually be stable. So I don't really know how people can purchase this. I mean, I know that memory stress tests are not realistic scenarios, but in my experience, Warzone is also very sensitive to memory errors. So I don't know how anyone could run Warzone on those kits, and I guess also other production software would probably have some issues in the long run. But then again, I had experience with clients. They would claim like, oh yeah, my computer works fine, it just crashes every now and then, maybe twice a week, and I was like, that's not normal. And and then I run YCruncher and system crashes, reboots instantly. So that's what happens when you buy from random people on the internet or even on stores. Like, it's not about actually the location of the store, it's just about the fact that like random people would not run any kind of benchmark on their machine other than Cinebench and then call it a day and sell it to the clients. But oh, this seems to be working with YCruncher. But then again, in my experience, it's the long test that they actually crash with those 96 gigs kicked at default at stock voltages. But the fact that this is running means, yeah, this is working, and we're running at 6400. So this means that this kit is trash, because if 96 gig works at 64 and this doesn't, which is only 64 gigs, that means that the Viper kit is bad, just bad. The motherboard is actually able to drive dual rank at 64, so it's all the Viper kit fault. Well, that's interesting to know. So I want to do another test now, which is take a 12400, let's see, H0 die, so 6 pure cores, and for some reason this works. So light load works with the 12400F. You can see it, 66 watts. We're running with XMP enabled, so the RAM is 3200, no problem, and 96 gigabytes. Yeah, so also running at system agent of 95, and I'm going to show you. And I will also try to set also another volt for with the offset and see if it works, because in the latest BIOS revisions I was able to also apply an offset to the locked H0 CPU. So MSI is really like working backwards for some reason. For locked CPU it works. So let's see, minus 0.05, I would guess, makes sense. And I will show you that we're actually light load 1, because without light load 1 it would pull 82 watts, 82, 83 watts, and now it's pulling 68. And with the offset, let's see if that changes. Okay, we're under 1 volt for the CPU core at 4 gigahertz. We're pulling 61 watts, so the offset is working. And since we're not pulling 30, but we're pulling like a reasonable amount of watts, that means that the offset is working. That means we're going to have the proper score in the end. So really, MSI, why is the word backwards? Why offset undervolt and light load are working with the locked CPU, but are not working with an unlocked CPU? This does not make any sense to me. We only lost 4 watts, and the score actually decreased slightly. Maybe it was because of some other stuff. Let's get to crash. So minus 100. In my experience, 12400Fs usually undervolt about 150, 130 to 150. So 100 plus light load should not work. We should get a blue screen maybe, but let's see. I don't know really. I might have a lucky one. Also the cooler, I put another cooler on because the Noctua is smaller. This one is taller and higher and heavier, even if it's worse quality. But let's see what happens. It seems to be stable. So we were at 68 without offset. We were at 63 with minus 50, and we should be at 60 now. That's my guess. it's still stable. We're running at 55 watts. We should stop at 60 at some point. And it's stable, so that's amazing. I love it. We're pulling 55 watts. Oh god. Previously we were pulling, if I remember correctly, around 200 watts for 26 seconds, and we're now pulling 59, just as expected, for 40 seconds. So we're 1/4 the power and less than half the performance. So I mean, it's like you're getting 60% of the performance at 25% of the power, and that speaks for itself. I guess that's all for this video. Really, MSI, you're screwed up. I don't know really what else to say, but thanks for loading everything and get it right with the KF. Ciao.